minus y square equivalent to x square minus y square equivalent to 105. xy are natural numbers. How many values xy will take? How many values xy will take? Same question, some more examples which we will solve. These are nothing but x plus y into x minus y is 3 into 5 into 7. 3 into 5 into 7. So this, if I write it as a into b is 3 into 5 into 7. These 2 into 2 into 2, 8 cases. In that 8 cases, 4 cases will be a greater than b. 4 cases will be a less than b. A less than b. 4 cases will be a greater than b, a less than b. Sum of two natural numbers. Sum of two natural numbers can never be less than x minus y. These 4 cases are eliminated. Answer for this question is 4. Answer for this question is 4. X plus y is a, x minus y is b. A into b is 3 into 5 into 7. 3 into 5 into 7, which is 8. 4 cases will have a greater than b, 4 cases will have a less than b. Sum of two natural numbers can never be less than their difference. So 4 cases are eliminated. 2 more examples we will solve, then the idea will be extremely clear to you. Next, please write down. X square minus y square equivalent to 3 power 6 into 5 square into 7 power 3. xy are natural numbers. How many values xy can take? How many values xy can take? X square minus y square equivalent to 3 power 6 into 5 square into 7 cube. This is x plus y into x minus y equivalent to 3 power 6 into 5 square into 7 cube. How many factors are there for this number? 7 into 3 into 4, which is nothing but 84. In that 84, 42 cases will have x plus y greater than x minus y. 42 cases will have x plus y less than x minus y. Sum of two natural numbers will never be less than their difference. So answer for this question is 42. Kindly reply in the live chat if it is clear to you. If this concept is clear to you, kindly reply it in the live chat. 7, 3, 4. 21 4s are 84. 42 cases will have x plus y greater than x minus y. 42 cases will have x plus y less than x minus y. 42, 42. Answer for this question is 42. Sum of two natural numbers will always be greater than their difference. Next, one more question. One more question. Please write it. Please write it. One more question. X square minus y square is 3 power 100. We are taking the right hand side where it is an odd number. How many values xy will take? How many values xy will take? Right? 3 power 100. It is nothing but total 101. 101 is 50 here, 50 here, 1 here. This case is eliminated. This case is eliminated. This is the answer. Answer is 50. There could be, depending upon the right hand side perfect square, 2 logics will come. So I am not discussing any logic. This is the case where x plus y is greater than x minus y. This case is x plus y equivalent to x minus y. This case is x plus y less than x minus y. 51, it is eliminated. So answer for this question is 50. Answer for this question is 50. I hope it is clear. What we discussed the logic where x square minus y square equivalent to k, where k is an odd number. where k is an odd number we discussed. Where k is an odd number we discussed. Now let us discuss what if the right hand side is a multiple of 4. What if the right hand side is a multiple of 4? Karthik, you are right, but be careful if the right hand side is a perfect square or a non-perfect square. Next question. Please write down. Next one. Please write down. X square minus y square. Easy question we will solve. X square minus y square equivalent to 60. XY are natural numbers. How many values XY will take? X square minus y square is 60. XY are natural numbers. How many values XY will take? This is nothing but x plus y into x minus y equivalent to 60. It is equivalent to 60. 60 is divisible by 4. 60 is divisible by 4. Already we discussed x square minus y square equivalent to k. X plus y into x minus y equivalent to k. If k is divisible by 4, x plus y is even and x minus y should also be even. This is what we concluded. No small change. 2k1 into 2k2 is 60. k1 into k2 is 15. Now use the logic. 15 is 3 into 5. Total 2 into 2, 4. 2 cases here, 2 cases here. These 2 cases are eliminated. Answer for this question is 2. If the right hand side is divisible by 4, if the right hand side is divisible by 4, all you have to do is make x plus y an even number, make x minus y an even number. Rest all the cases are similar. Make x plus y as an even number and x minus y as an even number. 2k1 into 2k2 is 60. k1 into k2 is 15. 15 will give you the case. 15 will give you the case. 3 into 5. 2 2s are 4. 4 means 2 cases k1 less than k2, 2 cases k1 greater than k2. Answer for this question is 2. Next, 2 or 3 more questions, then this concept is clear to you. Right hand side is an odd number over right hand side is divisible by 4. Next one. Second question. X square minus y square equivalent to 2 power 100. X square minus y square equivalent to 2 power 100. XY are natural numbers. XY are natural numbers. How many values XY will take? This is nothing but x plus y into x minus y. It is 2 power 100. 2 power 100 is divisible by 4. So, it is only possible when the left hand side each number is an even number. It is 2 power 100. k1 into k2, it is nothing but 2 power 98. 2 power 98 is 99 cases. 49 case here, 49 case here, and it is 1. This is k1 equivalent to k2. This is k1 less than k2. This is k1 greater than k2. These two are eliminated. So answer for this question is 49. I hope the logic is clear. Just divide the right hand side by 4, you will get the answer. Right hand side by 4, you will get the answer. k1 equivalent to k2, k1 less than k2, k1 greater than k2. One more question. I hope the idea is clear. One more question. X square minus y square equivalent to 60 whole square. XY are natural numbers. XY are natural numbers. How many values XY can take? X square minus y square equivalent to 60 whole square. This became x plus y into x minus y equivalent to 2 square into 3 into 5 whole square. This is nothing but 2 power 6 into 3 square into 5 square. This should be an even number. This should be an even number. So K1 into K2, it is nothing but 2 power 4 into 3 square into 5 square, which is 5 into 3 into 3, which is 45. 22 here, 22 here and 1. Both are eliminated. Answer is 22. I hope this logic is clear. If the right hand side is an odd number and the right hand side is a multiple of 4, kindly reply in the live chat if it is clear to you. If it is clear to you, kindly reply in the live chat. Kindly reply in the live chat. 45, 22, 1, 22. 1 and 22 are eliminated. Answer for this question is 22. Answer for this question is 22. Factors and multiples, section 4. I think few important key points are pending. I will discuss that important key points after this doubt. Question. X square minus y square equivalent to 1, 2, 3, 4. X comma y are natural numbers. How many values x, y can take? X square minus y square equivalent to 1, 2, 3, 4. X, y are natural numbers. How many values x, y will take? This is the question. So, method 1. What is the concept that we discussed? Concept is x square minus y square equivalent to k. If x and y are natural numbers, this equation has integral solutions. These equations has integral solutions. Praveen, keep this phone for charging. These integral solutions only if k is an odd number or k is a multiple of 4. This is the first method which we discussed. K is a multiple of 4. If x square minus y square equivalent to k, this equation has integral solutions only if k is an odd number or k is a multiple of 4. Right? So based upon this concept, we got the answer 0. We got the answer 0. Now method 2. Can I use any other method? Yes, you can use some other method. Method 2. Please write down a note. Write down a note. A perfect square never ends with, a perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Why it will not end with 2, 3, 7 or 8? You take the unit digit of any number. Unit digit of any number ranges from 0 to 9. 0 square 0. I'll write down the proof also here. In case if you are watching it for the first time. Unit digit of any number ranges from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. All the possible unit digits are from 0 to 9. 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. Anywhere in the right hand side, I got 2 at the end? No. 3 at the end? No. 7 at the end? No. 8 at the end? No. A perfect square never ends with 2, 3, 7 or 8. Please write down this, then we will apply this concept. If a number is a perfect square, it will never end with 2, 3, 7 or 8. If a number is a perfect square, it will never end with 2, 3, 7 or 8. 2, 3, 7 or 8. How this concept can be used? How this concept can be used to solve the question? Praveen? Rambabu, pen. How this concept is used to solve this question. Write down method number 2. Method number 2. Method number 2. X square minus y square equivalent to 1, 2, 3, 4. 1, 2, 3, 4. XY are natural numbers. XY are natural numbers. How many values XY can take? X square minus y square equivalent to 1, 2, 3, 4. How many values it will take? See here how I am solving this question. X square minus y square is 1, 2, 3, 4. See here, I will play around with the unit digit of a logic. I will play around with the unit digit of a logic. Now see here, what is the unit digit in the right hand side? 4. If the right hand side unit digit is 4, can I say one way is 4 minus 0 is 4. 4 minus 0 is 4. 5 minus 1 is 4. 6 minus 2 is 4. 7 minus 3 is 4. 8 minus 4 is 4. 9 minus 5 is 4. If it is 1, 10 carried. 11 minus 7 is 4. If it is 2, 10 carried. 12 minus 8 is 4. If it is 3, 10 carried. 13 minus 9 is 4. What are all these numbers? All these numbers are the possible unit digits. These are the possible unit digits of a number. 4 minus 0, 4. 5 minus 1, 4. 6 minus 2, 4. 7 minus 3, 4. 8 minus 4, 4. 9 minus 5, 4. 11 minus, these 1 carry, sir. 10, 11 minus 7 is 4. These again a 1 carry. 12 minus 8 is 4. These again 1 carry. 13 minus 9 is 4. X square comma y square are perfect squares. X square comma y square are perfect squares. A perfect square cannot have unit digit 2. A perfect square cannot have unit digit 3 or 7. A perfect square cannot have unit digit 8. A perfect square cannot have unit digit 3, 7 or 8. Only 3 cases are remaining. Now if you observe, any perfect square ending with 4, tens place is 0. Why? Because 8 square is 64. 12 square is 144. 18 square is 324. Any perfect square ending with 4, tens place is even. A perfect square ends with even number of zeros. 10 square 100, 20 square 400 and everything. Any perfect square ending with 5, tens place is always 2. 5 square 25, 15 square 225, 25 square 625. Any perfect square ending with 1, tens place is even. 9 square 81, 11 square 121, 19 square 361, 21 square 441. Any perfect square ending with 9, tens place is even. Any perfect square ending with 5, tens place is 2. All these remaining cases are eliminated. Why? Because a perfect square never ends with 2, 3, 7 or 8. Now if you see the logic, even minus 0 is even. Even minus even is even. Even minus 2 is even. Tens place should be even. Tens place should be even. According to this perfect square logic, tens place should be even. But tens place given in the question is odd. Answer is no value for x comma y. Another beautiful way to solve the question using the unit digits logic. Using the unit digit logic. X square minus y square is 1, 2, 3, 4. Right hand side unit digit is 4. Right hand side unit digit is 4. Right hand side unit digit 4. When you subtract 0 from 4 in the first case, 1 from 5 in the second case, 2 from 6 in the second case, 3 from 7 in the third case, 4 from 8 and everything. A perfect square never ends with 2, 3, 7 or 8. All these cases are eliminated. The only case is first, second and third. A perfect square ends with even digit if the unit digit is 4, because 8 square 64, 12 square 144. Perfect square ends with even number of zeros. Even minus 0, even. A perfect square ending with 5 tens place is 2. Ending with 1 tens place is even. Even minus even, even. Even minus even, even. Tens place should be even. But according to the question, tens place is odd. Therefore, answer is no value for x comma y. Anil Nair's way of solving this question just based on a perfect square concept. Now write down another note. I hope it is clear. Now write down another note. What did we get? X square minus y square equivalent to k. X comma y are natural numbers. These are nothing but x plus y into x minus y equivalent to k. If I take the cases, x is an even number, y is an even number. X is an odd number, y is an odd number. X is an even number, y is an odd number. X is an odd number, y is an even number. Even number plus even number, this is an even number. Even number minus even number, it is an even number. Odd plus odd, it is an even number. Odd minus odd, even number. Even into even, it is divisible by 4. Even into even, it is divisible by 4. X is even, y is odd. Even on square is even. Odd on square is odd. Even minus odd is odd. Odd on square is odd. Even square is even. Odd minus even is odd. Right hand side I got divisible by 4 and an odd number. I do not need this. Suppose if I extend it, x power 4 minus y power 4 equivalent to k. X, y are natural numbers. These are nothing but x minus y into x plus y into x square plus y square equivalent to k. Here x and y are natural numbers. X is even, y is even. X is odd, y is odd. X is even, y is odd. And x is odd, y is even. Once you understand the root cause of the problem, these are all very easy questions. Even minus even is even. Even plus even is even. Even square plus even square, it is even. Even into even, it is divisible by 8. This case. Odd minus odd, even. Odd plus odd, even. Odd square plus odd square, even. Third case, if I take even power 4, even. Odd power 4, odd. Even minus odd is odd. Similarly, odd power 4, odd. Even power 4, even. Odd minus even is odd. That means, if x power 4 minus y power 4 equivalent to k, it has integral solutions. It has integral solutions only if it is divisible by 8 and it is an odd number. And it is an odd number. Extremely important conclusion. If it is 2, I got 2 into 2, 4 are an odd number. If it is 4, I got 2 into 4, 8 and an odd number. If the power is 8, I will get 2 into 8 and an odd number. 2 into 8 and an odd number. Extremely important pattern based question. If it is 4, right hand side is divisible by 8. 2 into 4. If it is 2, it is 2 into 2, 4. Now we will write a conclusion. This is example 1 and it is example 2. Example 2. Like that, anything you can, anything power 2 power n, you can solve it. We will write down for that one. X power 4 minus y power 4 equivalent to k. Now we will write down x power 2 power n minus y power 2 power n equivalent to k. If the equation is like this, x power 2 power n minus y power 2 power n equivalent to k. These has integral solutions. These has integral, Rambabu. These has integral solutions. These has integral solutions only if k is a multiple of 2 into 2 power n and k is an odd number. Please write down. X power 2 power n minus y power 2 power n equivalent to k. These equation has integral solutions only when k is a odd number or k is a multiple of 2 into 2 power n. X power 4 is 2 square, 4 is again 2 square equivalent to k. This has integral solution when k is 2 into 2 square or k is an odd number, or k is an odd number, or k is an odd number. I hope the idea is clear. I hope the idea is clear. I hope the idea is clear. We will understand this idea based upon a question. X power, this is a very important repeated pattern, sir. X power 2 power n minus y power 2 power n equivalent to k has integral solutions only if k is an odd number or k is a multiple of 2 into 2 power n. Example. X power 4 minus y power 4 equivalent to 1, 2, 3, 4, 5, 6, 7, 8. XY are natural numbers. XY are natural numbers. How many values x will take? X power 4 minus y power 4 equivalent to 1, 2, 3, 4, 5, 6, 7, 8. XY are natural numbers. How many values xy will take? This will have integral solutions. This will have integral solutions when the right hand side is either an odd number or divisible by 8. Either an odd number or divisible by 8. Divisibility rule of 8 is last 3 digits should be divisible by 8. 678 divided by 8. 8 8s are 64. 38. It is not equivalent to 0. So answer for this question is no value for x comma y. No value for x comma y. No value for x comma y exists. I hope the idea is clear. No value for x comma y exists. Beautiful question. X square minus y square we did it. Then we did x power 4 minus y power 4. Right hand side last 3 digits should be divisible by 8. Should be divisible by 8. Now please make a note. Another important key point. Another important key point. What is this key point? I should have said it when I dictated that question to you. Question is x square minus y square equivalent to 65 whole square. XY are natural numbers. How many values xy will take? How many values xy will take? This question is similar to. This question is similar to. How many right-angled triangles exist? How many right-angled triangles exist? Please write down the question. How many right-angled triangles exist? How many right-angled triangles exist? Such that 65 is a side. 65 is a side. Side not equivalent to hypotenuse. Side not equivalent to hypotenuse and has integral sides. And has integral sides. Both the question meaning is similar. Both the question meaning is similar. X square minus y square equivalent to 65 square. XY are natural numbers. So these is nothing but, if I take 65 as one of this side, according to Pythagoras theorem, let me call it as x, let me call it as y to get the same equation. x square is nothing but 65 whole square plus y whole square. This is nothing but x square minus y square equivalent to 65 whole square. Both the questions are quite similar to each other. X square minus y square equivalent to 65 square. How many right-angled triangles exist with integral side and 65 has one of their side? 65 has one of their 65 as one of their side not equivalent to hypotenuse. I hope this key point is clear. So the way that you are solving this question is similar. Both are semantically correct. Meaning is the same. I hope you got the idea. Now one student might ask me, Anil sir, what if instead of minus if there is a plus? Please write down. Another note, I hope it is clear. Both are, one is a geometric representation, another is an algebraic representation. Question, x square plus y square equivalent to 1239. X square plus y square equivalent to 1239. X and y are natural numbers. X and y are natural numbers. How many values xy will take? X square plus y square equivalent to 1239. Xy are natural numbers. How many values xy will take? Solution. Same. If x and y are natural number, x can be even, y can be even. X can be even, y can be odd. X can be odd, y can be even. Last case, x can be odd, y can be odd. These are the four cases. X is even, y is even. X is even, y is odd. X is odd, y is even. X is odd, y is odd. If x and y are even numbers, even number is nothing but of the form 2k1. 2k1 whole square plus 2k2 whole square. 2k1 whole square plus 2k2 whole square. 2k1 whole square, it is divisible by 4. It is divisible by 4. If one is even, another is odd. One is even number is 2k1 whole square. Another is an odd number 2k2 plus 1 whole square. If you observe, 2k1 whole square is 4k1 square. This is nothing but 4k2 square plus 4k2 plus 1. This is nothing but divisible by 4. This is nothing but divisible by 4. This is nothing but divisible by 4. What is the remainder that you got? 1. What is this case? This is the case where one is an even number, other is an odd number. This is a case where one is even and another is odd. X is odd, y is odd. 2k1 plus 1 whole square. 2k2 plus 1 whole square. 2k1 whole square, 4k1 whole square, it is divisible by 4. 2 into 2k1 divisible by 4. 4k2 square divisible by 4. 2 into 2k1 divisible by 4. 2 into 2k2 divisible by 4. 1 plus 1 is 2. It gives a remainder y square equivalent to 1239. Xy are natural numbers. How many values xy will take? How many values xy will take? This is the question. What is the conclusion that we have drawn? The conclusion is x square plus y square equivalent to k. X square plus y square equivalent to k. K is either divisible by p, or it gives a remainder 1, or it gives a remainder 2. What is this case? This case is when x is an odd number and y is an odd number. X is an odd number, y is an odd number. What is this case? When x is an even number and y is an even number. What is 4p plus 1 case? When x is even, y is odd, or when x is odd, y is even. y is even. X square plus y square equivalent to k. It has integral solutions. It has integral solutions only if right hand side is either divisible by 4 or gives a remainder 1 or 2. Now once you understand this one, this question is a pretty simple cakewalk for you. X square plus y square equivalent to 1239. Last two digits of should be divisible by 4. 39 is 4 into 9 plus 3. 4k plus 3 form does not arise. So answer for this question is no integral solution. No integral solution. X square plus y square equivalent to k. It has integral solutions only if the right hand side is divisible by 4 or it gives a remainder 1 or it gives a remainder 2. 4p plus 1, 4p plus 2. 4p plus 3 cannot arise. 4p plus 3 cannot arise. I hope it is clear. 4p plus 3 form cannot arise. What if it is 4p plus 1, 4p plus 2? I took a number which is of the form 4 into k plus 3. Let me take another number. Two examples which we will solve. X square plus y square equivalent to 100. X square plus y square equivalent to 82. X square plus y square equivalent to 82. Very easy solution it is if you know it. Unit digit of x square and y square. If it is 2, 2 plus 0 is 2. Am I right? 3 plus 9 is 2. 4 plus 8 is 2. 5 plus 7 is 2. 6 plus 6 is 2. 7 plus 5, 8 plus 4, 9 plus 3 and everything. 1 plus 1 is 2. These are all the unit digits of the left hand side and the right hand side. 2 plus 0, all the digits we got. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9, all the cases we got. So unit digit is 0. Unit digit is 0. Now see here. A perfect square cannot end with 2. Perfect square cannot end with 3. Cannot end with 7 or 8. 7 or 8. Any perfect square ending with 6, tens digit is odd. Any perfect square ending with 6, tens digit is odd. 4 square is 16. 6 square is 36. 14 square is 196. 16 square is 256. Any perfect square ending with 1, tens digit is even. Tens digit is even. Tens digit is even. Now if you see this logic, this is out, not possible. Why? Because 6 plus 6 is 12. 2, 1 carried. Odd plus odd is even. Even plus 1 odd. But I want this is 8. It is not possible. Next it is, if it is 1, what is the case that is possible? For it to become 8, this can be 0, this can be 8. Am I right? 0, 1 plus 81. So answer is x can be plus or minus 1, y can be plus or minus 9. Or x can be plus or minus 9, y can be plus or minus 1. Remaining cases are not possible. 21 plus 61. 21 plus 61, which is 82. 1 plus 1, 2 we got. This should be even, this should be even. 0, 1 plus 81. 21 plus 61. 41 plus 41. Only these are the case. Am I right? So I require 82. If I require 82, what is the smallest perfect square on square? I will get 21. 11 square is 121. Not possible. 21 square is 441. 21 square is 441. Not possible. Only case is only case possible is x value is 1, y value is 9, or x value is 9, y value is 1, plus or minus, plus or minus, plus or minus, plus or minus. Please ask a doubt if it is not clear to you. X square plus y square equivalent to 82. Unit digit is 2. 2 plus 0, 2. 1 plus 1, 2. 3 plus 9, 2. 4 plus 8, 2. 5 plus 7, 2. 6 plus 6, 2. A perfect square never ends with 2, 3, 7 or 8. 1, 2, 3, 4. All the cases are eliminated. 6 plus 6 is 12. 2, 1 carried. Odd plus odd is even. Even plus 1 is odd number. It is out. Even 1, even 1. What are the cases? 0, 1 plus 81. 21 plus 61. 41 plus 41. 21, 61 not possible. 41 not possible. Only case possible is 0, 1 and 81. I hope this logic is clear to you. Kindly reply in the live chat if it is clear to you. If it is clear to you, kindly reply in the live chat. Kindly reply in the live chat if it is clear to you. X square plus y square equivalent to 82. X square plus y square equivalent to 82. Right? Now this is an even number, Banu. This is an even number. This is an even number. If I keep 0, 0, 1 plus something is 82. This something has to be. Because it is even number, I kept all the even digits 0, 2, 4, 6, 8 such that the sum is 82. Such that the sum is 82. Such that the sum is 82. How you got? How 1 and 8? Now if you see here, 1 plus 1 is 2. These tens place is 8. How do we get tens place plus from even to even? 0 plus 8 is 8. 2 plus 6 is 8. 4 plus 4 is 8. I hope it is clear. I hope it is clear. X square plus y square equivalent to 82. All these cases are eliminated. All these cases are eliminated. I hope it is clear. Right. Or what you can do is x square plus y square equivalent to 82. For it to get the approximate value, keep the lowest value of x 0. Y square is nearer to 82. Y is 9. 81. X will be 1. But these will not work always. In this problem it is working. In this problem it is working. I hope I will take one more question so that it will be clear to you. I will take, Usha is asking me to repeat with one more. Balashiva, in this question, make x 0 is giving you answer, but you cannot say that that is the best method. You cannot say that that is the best method. One more question. One more question. Please write down. X square plus y square equivalent to 1544. X square plus y square equivalent to 1544. If xy are natural numbers, how many values? Natural numbers I am taking. Previous, if it is a natural number, -1, -9 will not come into picture. I took it as integral solution. Please make a note. Another question for you. Usha, Kavita, I am repeating it. X square plus y square equivalent to 1544. X square, Rambabu. X square plus y square is 1544. Xy are natural numbers. Listen carefully. This is x square. This is y square. Plus, it is nothing but 1544. It is 1544. It is unit digit 4. It is unit digit 4. 0 plus 4, 4. These are all the unit digits. These are all the unit digits. 0 plus 4. 1 plus 3, 4. 2 plus 2, 4. 4 plus 0, 4. 5 plus 9 4, 6 plus 8 4, 7 plus 7 4, 7 plus 4. I hope these logic is clear. 0 plus 4 4, 1 plus 3 4, 2 plus 2 4, 5 plus 9 14 4, 6 plus 8 14 4, 7 plus 7 14 4. A perfect square never ends with 2, 3, 7 or 8. All the distinct factors for 72. How many distinct factors? Charging bettese. Key point 6 తర్వాత తీసుకుంటా. How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? Now, method 1. Method 1. The generic approach. The generic approach, method 2. Method 2 is nothing but the derived approach. Method 2 will give you the answer fast. Method 2 is the derived approach. Method 1 is the generic approach. Method 2 is the derived approach. Suppose if I take 72. If I take 72, what are the factors of 72? Let me write down all the factors of 72. 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, 9 is a factor, 12 is a factor, 18 is a factor, 24 is a factor, 36 is a factor, 72 is a factor. These are all the factors which are factors of 72. Am I right? Am I right? 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. This is step 1. This is step 1. Step 1. Write down all the factors. Step 2. Step 2. Now read the question. Question says, how many distinct factors? Underline these distinct. No two should be same. Factors for 72 are co-prime to each other. Are co-prime to each other. They are co-prime to each other. They are co-prime to each other. What do you mean by co-prime? Co-prime is nothing but HCF should be 1. HCF of A comma B should be 1. Then only A and B are said to be co-prime to each other. Two numbers are said to be co-prime if their HCF is 1. Two numbers are said to be co-prime if their HCF is 1. Now if you observe, 1 is co-prime with 2, 1 is co-prime with 3, 1 is co-prime with 72. 1 comma 1 cannot be taken. Why? Because the question is distinct. The question is distinct. So 1 comma 1 cannot be taken. 1 comma 1 cannot be taken. Totally, how many numbers are there which are co-prime to each other? 2, 3, 6, 9, 11. There are 11 numbers. There are 11 numbers which are co-prime with 1. Am I right? First step. How many numbers are co-prime with 1? Next step. How many numbers are co-prime with among each other? 1 with 2, 1 with 3, 1 with 72. There are 11 numbers. There are 11 numbers which are co-prime with 1. There are 11 numbers which are co-prime with 1. Am I right? Step number 3. Step number 3. 72 is nothing but 2 cube into 3 square. Total factors for 72 are, total factors for 72 is 4 into 3, 12. Total factors for 72 is 12. factors which are co-prime with 1, factors which are co-prime with 1, they are 11. Factors which are co-prime with 1, it is nothing but 11. Factors which are co-prime with 1, it is 11. Now, if you see, what are they? 1, 2, 1, 3, 1, 4, and so on up to 1, 72. Am I right? Next one. Factors which are co-prime among themselves. Factors which are co-prime among themselves. Co-prime among themselves. What is that? If you see, n is 2 power 3 into 3 square. This is 2 power 0, 2 power 1, 2 power 3. 3 power 0, 3 power 1, 3 power 2. 1 is taken out. 2 and 3 are co-prime to each other. 2 and 9 are co-prime to each other. 4 and 3 are co-prime to each other. 4 and 9 are co-prime to each other. 8 and 3. 8 and 3. 8 and 3 are co-prime to each other. 8 and 9 are co-prime to each other. Am I right? So, other than 1, remaining which all powers of 2 are co-prime with which all powers? All the powers. Everything with other is co-prime with each other. 2 with 3, 2 with 9. 4 with 3, 4 with 9, 8 with 3, 8 with 9. Totally what will be the answer? 6. So either factors which are co-prime with 1 is 11 or numbers which are co-prime among themselves is 6. 11 plus 6 is 17. 11 plus 6 is 17. How many factors for 72 are co-prime with each other? It is a two-step solution. Factors which are co-prime with 1 we have to take. Otherwise, eliminate the powers of 2. All the powers of a prime number with every other prime number powers. Prime number powers. 11 plus 6 is 17. This is a generic method. This is a generic method. Now we will optimize this method. This is a generic method. 2 with 3, 2 with 9, 4 with 3, 4 with 9, 8 with 3, 8 with 9, total 6. 11 plus 6 is 17. Now we will generalize it. I hope it is clear. Now we will generalize it and create a conclusion. Generalization. If I generalize it, n equivalent to P1 power A into P2 power B. Step 1. Total number of factors for this number. Total number of factors for n will be 0 to A plus 1, 0 to B plus 1. Step 1. Step 2. Factors which are co-prime with 1. Factors which are co-prime with 1. Factors which are co-prime with 1. 1 is co-prime with every other number. Because it is distinct, we should not do 1 with 1. All the other remaining numbers are A plus 1 into B plus 1 minus 1. Previous example you see 1 with 2, 1 with 3, 1 with 4, 1 with 72. Out of 12, 1 is co-prime with every other number. Every other number it is 11 we got. Step number 3. Step number 3. This is nothing but P1 power A. P1 power 1 into P1 power A. P2 power 1 into P2 power B. Every power of P1 is co-prime with every power of P2. So factors which are co-prime among each other. Factors which are co-prime with among each other. Factors which are co-prime among each other? It is nothing but A into B. So the total answer is A plus 1 into B plus 1 minus 1 plus AB. These AB plus A plus B plus 1 minus 1 plus AB. Answer is A plus B plus 2AB. What are AB? AB are nothing but the powers of the prime numbers. Please make a note of it. I hope the logic is clear. Why it should be A plus B plus 2AB. Why it should be A plus B plus 2AB. I hope the logic is clear to you. I hope the logic is clear to you. Mobile disco. Kindly ask me in case if you got a doubt in any of the logics. A plus 1 plus into B plus 1 minus 1, right, plus A B plus AB. I hope it is clear. Kindly reply if it is clear to you. Kindly reply if it is clear to you. A plus 1 into B plus 1 minus 1 plus AB. It is A plus B plus 2AB. A plus B plus 2AB. Write down a question. Abhay, I think you are new to my channel, right? When a topic is there, attention only on that topic. Sujata, you can purchase and watch the session 1 again. A plus B plus 2AB. A plus B plus 2AB. Total number of factors is A plus 1 into B plus 1. Factors which are co-prime with 1. 1 is co-prime with every other number. It is A plus 1 into B plus 1 minus 1. That is with 1. Other than 1, 1 is P1 power 0, P2 power 0. So P1 from 1 to A is co-prime with 1 to B, which is nothing but A into B. A plus 1 into B plus 1 minus 1 plus AB. Conclusion is A plus B plus 2AB. Please write down this point. Distinct factors for n equivalent to P1 power A into P2 power B, which are co-prime to each other. Is given by the logic A plus B plus 2AB. A plus B plus 2AB. What are A and B? A and B are nothing but the powers of prime bases. A and B are nothing but the powers of prime bases. First we will do it for a 2 prime bases, then we will extend it to 3 prime bases, 4 prime bases. Haritha, I am going to explain that one. I am going to explain. I will not leave any concept in this one. I am sure you must be understood my style of teaching by now, in case if you have watched. Right? First we will do for 2, then we will extend it. Example, n equivalent to 2 power 4 into 3 square. Answer is nothing but A plus B plus 2AB. A plus B plus 2AB. 4 plus 2 is 6. 4 4s are 16. 16 plus 6 is 22. 16 plus 6 is 22. Suppose if it is 3 prime bases, 2 cube into 3 square into 5 power 4. 2 cube into 3 square into 5 power 4. Apply the rule of recursion. Take any 2. Get the answer. Do it with the third one. If I take these 2. Factors which are co-prime with 2 and 3. A plus B plus 2AB. A plus B plus 2AB, which I got 17 here. k power 17 into 5 power 4. What is this k? K is nothing but a set which are co-prime with 2 and 3. Again answer is a plus b plus 2ab. A plus b plus 2ab. 21 plus 68 2s are 136. Answer is 157. Take with any two and do it with the third one. You can take 2 power 3, 5 power 4, then do it with 3 power 2. Still the answer will be same. I hope Balaji you understood the point. For two numbers we will develop this and then we will extend it to any numbers. 2 power 3 into 3 square. A plus b plus 2ab. 17 which is k power 17 into 5 power 4 which is a plus b plus 2ab. One more example. N equivalent to 3 square into 5 cube into 7 power 4 into 11 square. Factors for n which are co-prime with each other. Factors for n which are co-prime with each other. Factors for n which are co-prime with each other. Answer for this question is take first and second, third and fourth. 2 plus 3 plus 2 into 2 into 3. 4 plus 2 plus 2 into 4 into 2. 2 plus 3 is 5. 5 plus 12 17. 4 plus 2 is 6. 6 plus 16 is 22. So this is a power 17 into b power 22. Again the answer is a plus b plus 2ab. 2 into 17 into 22. These are the 17 values which are co-prime with each other. I am writing it as a power 17. A and b are not prime numbers. A is that set which are co-prime among 3 and 5. B is that set which are co-prime among 7 and 11. Co-prime among 3 and 5. Co-prime among 7 and 11. From this answer is 17 plus 22 plus 2 into 17 into 22. 2 into 17 into 22. Numbers which are factors which are co-prime to each other. Next one. Key point number 5. First concept. Key point number 5. Suppose if I take an example, 15 is there. 15 is 1 plus 2 plus 3 plus 4 plus 5. 9 plus 3, 12, 14, 15. It is also 7 plus 8. It is also 4 plus 5 plus 6. 15 is nothing but 3 into 5. Please write down this point. I will discuss the proof in day after tomorrow, factors and multiples CAT level. There I will discuss number of ways of writing a number. Number of ways of writing a number as a sum of 2 or more. As a sum of 2 or more consecutive positive integers is given by total number of odd factors minus 1. Please write down. Total number of odd factors minus 1. Number of ways of writing a number. Number of ways of writing a number as a sum of 2 or more consecutive positive integers is total number of odd factors minus 1. Total number of odd factors minus 1. Right? Banu is telling total number of factors less than or greater than the factors which are co-prime to each other. I did not understood your line. Abhay, yes, it is total number of odd factors minus 1. If it is 1 or more, if it is 1 or more, it is nothing but total number of odd factors. Total number of odd factors. Why? Right now only I will give the proof. Why to wait for day after tomorrow? Number of ways of writing a number as a sum of 2 or more consecutive positive integers is total number of odd factors minus 1. 1 or more will be total number of odd factors. This is, I took it as an example. Now I will discuss the proof. Please write down proof. Please write down proof. Please write down proof. Please write down proof. Proof. Right, let the numbers are a plus 1, a plus 2 and so on up to a plus n. Let there are consecutive natural numbers from, not from 1 to n, a could be 0, a could be any value. Now if you see Sn is n by 2 into first term plus last term. First term plus last term. N by 2 into first term is a plus 1. Second term, last term is a plus n. So this is nothing but n into 2a plus n plus 1. If I take the number as example 15, these is nothing but 2 15s are 30. Through 15s are 30. I hope it is clear. It is 2 into a into n plus 1. Now if you see, if n is an even number, 2a is an even number. I hope it is clear, right? N by 2 into first term to last term a plus 1 to a plus n. N by 2 into first term is a plus 1, last term is a plus n. So n into 2a plus n plus 1 equivalent to 30. Just by looking at the question, we can say that 2a plus n plus 1 is greater than n. If n is even, this is even. Even plus 1. Even plus 1 is odd. If n is even, this number will be odd. If n is odd, this is odd. Odd plus 1, even. Any number multiplied by 2, it is even. Even plus even is even. That means either it is becoming even into odd or it is becoming odd into even. Already we discussed. In an unordered pair, number of ways of writing a number as a product of odd into even is nothing but number of odd factors. 1 or more consecutive positive integers, it is a number of odd factors. I hope the proof is clear. N into 2a plus n plus 1 is 30. If n is even, even plus 1 is odd. Any number multiplied by 2 even. Even plus odd is odd. So this is even into odd. If n is odd, odd plus 1 is even. Even plus even is even. In how many ways can you write a number as a product of odd into even? It is nothing but number of odd factors. It is nothing but number of odd factors. 1 or more. 2 or more means that one case we have to eliminate. That one case we have to eliminate. So answer is number of odd factors. Number of odd factors. Please write down a question. Please write down a question. Question. In how many ways? Question. In how many ways can 2004, in how many ways, or 2001 we will take, in how many ways can 2001 be written as a sum of two or more consecutive positive integers. Two or more consecutive positive integers. In how many ways can 2001 be written as sum of two or more consecutive positive integers? 2001 is 3 into 667, 3 into 29 into 23. Number of odd factors minus 1. Number of odd factors minus 1. So 8 minus 1 is 7. Number of odd factors minus 1. So answer is 8 minus 1, 7. 8 minus 1, 7. I hope the idea is clear. 8 minus 1, it is 7. Number of ways of writing a number as a sum of two or more consecutive positive integers is number of odd factors minus 1. Right?